Long ago, a flight from New York to London would take 3.5 hours, yet currently it takes about 7 hours to fly from New York to London. How was that really possible? An aeroplane named Concorde was the most notable passenger aeroplane that would travel at supersonic speeds. The Concorde's maximum speed was 2 times the speed of sound. It would fly people from London to New York in 3.5 hours. That is half the time it would take a typical aircraft to travel the same distance. But unfortunately, its last flight was in 2003.
The Concorde is no more.
Concorde will never take to the skies again.
But why can't we fly at the same speed now? Before we understand the why, let us first know what are supersonic aircrafts. What are supersonic flights? A supersonic flight is one of the 4 speeds or regimes of flight. There is subsonic, transonic, supersonic, and hypersonic. Aircrafts that are capable to fly at supersonic speeds are referred to supersonic aircrafts. They are able to fly at a speed faster than the speed of sound, that is 768 miles per hour at sea level. Or they are also referred to as Mach 1. These speeds are referred to by Mach numbers. For matters of information, a Mach number is a dimensionless quantity in fluid dynamics representing the ratio of the flow velocity past a boundary to the local speed of sound. It is also the ratio of the speed of the aircraft to the speed of sound. It was named after an Austrian physicist named Ernst Mach. If you're new here, my name is Seth, and in this video we're going to understand what are supersonic flights and why don't we have supersonic flights anymore. Anyway, is there hope that we are going to have supersonic flights again? So, without wasting much of the time, let's get into it. Now, as objects travel through air at supersonic speeds, air reacts like a fluid. Air molecules are pushed aside with great force, thus making a shock wave. A shock wave forms a cone of pressurized air, and a sharp release of pressure after the buildup of the shock wave forms a sonic boom. It sounds like boom, but it is always a continuous boom, 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 boom sounding after the plane has passed a certain point. So in simple terms, a sonic boom is a sound associated with shock waves when an object travels through air at speeds faster than the speed of sound. So a sonic boom is a loud thunder-like noise that is heard by a person on the ground when an aeroplane flying at supersonic speeds flies overhead. Sonic booms generate enormous amounts of sound energy to the surrounding, similar to an explosion or a thunderclap to a human ear. It is similar to the release of pressure when a pin pops a balloon and a loud noise is heard. NASA is studying and testing devices that could be used on aircrafts to reduce this sonic boom on supersonic aircrafts. Now, even after 22 years since its last flight, Concorde still fascinates people. With its power to fly at a speed twice the speed of sound, it even allowed passengers to experience 2 sunsets on its evening in London while departing to JF Kennedy in New York. Now, to achieve such speeds, Concorde had to be designed differently from other subsonic aircrafts. Its streamlined body and the triangular-shaped wings, plus a sharp pointed nose long enough, made it incredibly aerodynamic to break the sound barrier in air. The nose itself was quite an interesting piece of engineering, designed to change positions during different phases of flight. But why was it made so long? Concorde had a length of 62 meters, of which its needle-like nose was taking 7.5 meters of the length. To achieve the 2x speed, Concorde had to be designed very uniquely from any other aircraft. A very long nose could slice through air to reduce the drag. However, this shape that helped the aircraft to achieve the incredible speeds could also block or obstruct the pilot and the pilot's view. But engineers had to design a movable and adjustable nose during different phases of flight. The nose pointing straight forward posed no problems during the cruising altitudes, but only during landing and taking off. During takeoff and the initial climb, the nose would be lowered by 5 degrees to allow the pilot to have a view of where he is going. After the climb, the nose would actually be altered back again to its initial position. However, during landing, the nose was lowered 12.5 degrees to allow an uninterrupted view of the runway to the pilot. Then after landing, the angle would be reduced to 5 degrees to prevent potential damage of the nose from the ground. But How fast are supersonic aircrafts? When you say supersonic, it is now clear that supersonic aircrafts are faster than the speed of sound. But really, how fast? Okay, for matters of comparison, the world's fastest train goes up to 286 miles per hour. The world's fastest car goes up to 330 miles per hour. And the Boeing 737 goes up to 520 miles per hour. So once you reach 737 miles per hour, you have reached the speed of sound at sea level. Concorde used to go up to 1,350 miles per hour. Well, that is insanely fast. But after all that success, what really happened to supersonic aircrafts? Despite being studied by 250 British aeronautic engineers for over 500 hours of testing, Concorde flights came to a halt after 27 years of operation only. That was on 24th of October 2003, just even before I was born. The reasons were quite a handful, i.e. excessive costs, high fares, and loud noise. Talking about the costs, on a regular flight, Concorde would consume over 6,771 gallons of fuel, which actually exceeded the profit that was made on the flight. On top of that, only 20 Concordes were manufactured and no airlines ordered them, except Air France and British Airlines. Now, adding to the unprofitable cost of operation, the restriction of supersonic travel contributed to the downfall of Concorde. Since they flew at speeds twice the speed of sound, they were restricted to routes that passed over oceans. Because it sent a strong shock wave through the air it flew, thus causing shattering of window glasses in the residence area where it passed. Besides, when Concorde flew over a city, it would cause a very strong noise, thus increasing the number of complaints. Due to increased concerns of noise levels, they were also restricted to only transatlantic routes, taking off and landing in only New York, Washington, London, and Paris. Therefore, summing up all these challenges, it was later on summed up that Concorde should stop their operation, and they stopped their operation in October 24th of 2003. Now, here comes everyone's question. Is there hope for supersonic flights once again? Companies like NASA and Boom are working tooth and nail to prove to us that supersonic aircrafts can actually be made with a sonic boom eliminated. Now, a few years ago, NASA embarked on the project X-59 supersonic aircraft, but it is very clear that X-59 is not a passenger aeroplane. It is only meant for demonstration purposes that supersonic aircrafts can be manufactured but with no sonic boom. The sound it's going to be producing is similar to the sound produced by a car door. A door of the car heard from your neighbor's compound, which is actually pretty low, I think. It is really low. It is highly designed with a lot of considerations in mind, even unto the paint that is used on the supersonic X-59 aircraft. The paint that was used is an anti-static paint that reduces the static charge generated by the air during the flights. There is some other company called Boom Technology that has embarked on the project XB1, which is also a supersonic aircraft, and I think testing started in 2022, and these companies are really working hard to prove to us that supersonic aircrafts can be made but with no sonic booms. So if you have watched this video, I'm sure you've liked it, the information that has been put in. If you didn't watch my video about why airplanes fly very high, it is going to also be linked right here. And thank you for watching. I really value your time. Thank you for watching. If you haven't subscribed, please consider doing it. See you next time. Peace.